So just for kicks, here's a quick walkthrough of a couple of examples that demonstrate how to use other stream operations we've talked about, including intermediate operations and terminal operations, in order to do various things with the output of this simple search stream case study. So we're going to start out by visualizing the aggregate operations that are used in the WordSearcher.printResults method. So the idea here, if you recall, we have the names of the musical notes, do, re, mi, fa, sol, la, ti, do. I'll leave off the second do because it's redundant. And what we want to do is after we've gone through and searched the lyrics to the do, re, mi song, we want to print out where the different musical note names appear in the indices in the input string. And you can see this is what the output looks like. Do appears here, re appears here, mi appears there, and so on and so forth. And we're really doing this to demonstrate some other things, which is the use of collect and grouping by as a terminal operation. So to visualize this, we want to start out with a list of all the search results. This is what came back here. This is going to be these search result objects that corresponds to these words. And we turn that list into a sequential stream of search results. So now we have a stream of search results. And now we're going to go and collect these things using the grouping by terminal operation. And remember, collect will first trigger the intermediate operations. Nothing starts to run until the terminal operation is reached because streams are lazy. We'll talk more about lazy when we talk about the implementation details. And what we end up with here after grouping by runs is we have a map of the strings, do, re, mi, fa, and so on, and then a list of the results, which is where the names of the notes occurred within the do, re, mi song. So we're going to make a map that groups the words with the indices indicating where they're found. So the words are strings, which are the keys, and the places that they occur, the indices, are the values, which is a list of values. And so that then ends up creating this map. And then for each element in the map, we're going to print out the results. And this will iterate through all the key value pairs in the map. Notice that this is the forEach method on map, not the forEach method on a stream. So this is just reiterating that point. That's the forEach method that comes off of the map that's returned by collect. So this is not two terminal operations joined together, which would be uncharacteristic. Instead, it's one that makes a map, and then we go ahead and walk through the elements in the map. And then it'll go ahead and print the results out. And of course, remember, forEach does not return anything, so it'll basically be nothing at the end of that. So that's visualizing the results of this method, or of the print results method. So now that we've visualized the results, let's go ahead and show how to implement this. And this will be the print results method, and it'll show more details in the code. And once again, the purpose of this is to show collect and grouping by, as well as the mapToInt aggregate operation. So here's the method print results. You can see it takes a list of search results. And the first thing it does, as is so often the case with Java, is it converts that into a stream. So now we have a stream of search results. Then we call collect. And what that does is it takes each of the search result objects and it groups them using grouping by. And you can see we pass in several method references and the results of calling a function. So the search results : get word method is simply going to go ahead and extract the word, like do, re, mi, and so on, from that search results object. That becomes the key in the map. And the downstream collector we'll talk about later. We'll talk about that when we get probably next, maybe on Wednesday, we'll talk about that. So that's going to create a collector to collect all the list elements. The type of map that we create is a linked hash map. What the heck is a linked hash map? A linked hash map is a very interesting data structure that uses hashing in order to be able to map the keys to different parts of the hash table so that you can do rapid insertion, deletion, and find. But it keeps track through a linked list of the order in which you inserted things into the map. And that way, if you want to iterate through stuff, as we do here when we get to the forEach method, as we'll see in a second, that way we can print them out in order, because we want them to come out as do, re, mi, fa. We don't want them to come out in the order that they are put into the hash map in some random hashed order. And then the two downstream collector is a factor method that creates a downstream collector that merges the result list together. We'll talk about that when we get into implementing custom collectors later. And so the final thing here is that we're printing out the results. So for each of these things, we're going to print the results. This is, again, the map for each method, not the stream for each method. Let's go take a look at print result. So this is print result right there. So what print result is going to do is it's going to take a word and a list of search results.result objects. And the reason it does that is because that's the keys and the values that are in the map. So the map creates this key value mapping. It's a map is a mapping of keys to values. And the keys are the strings, the words, and then we have the list, which is the list of search results result objects. So we print out the word like dough, and then we go ahead and we print the results here. So we call print results with the list of results. And then we go ahead and compute the max index just for fun to show out something else. So here's compute max. Compute max takes a list of search result objects, turns that list into a stream. So we now have a stream of result objects, which are the indices where things matched. We use mapToInt, which will go ahead and grab the index of each of the results, like 117, 2005, whatever. And then we use the max method, which will find the max value. And so that returns an optional int that describes the maximum element in the stream, or an empty optional if the stream is empty. The stream will not be empty in this case, but if it were to be empty, we have to prepare for it. So that's why we use the or else method, which, as you can see, will return 0 if there was nothing in the stream. It's not the case here, but we just have to prepare for that. So this is a good example of using mapToInt to turn that stream of result reference types into a stream of ints. Then we can use max on that to get the maximum value. So that's the end of that implementation discussion.